Okay, got an update. It's been a while. I tried to do it last week and kind of getting done. This video is about the Unreal Engine and machine learning AI and doing object detection. And the object detection is not happening right now inside of Unreal. I'll be working on another example of how to do that later on down the road. Right now, what we're doing is experimenting with sending images back and forth, and right now sending them to the OpenCV Deep Neural Network API. So, and you can follow some of my other videos on this. So basically what's happening, we have an environment, just a very simple roller example in Unreal, and I have some of these free assets, which are these people that I loaded in, and you can get those off the Unreal Asset Store. Okay, so I have those placed around, and then what we have is a Unreal Python character. And I go through this a little bit in the earlier video. I suggest watching that. But this character basically has a camera attached to it right down here. And I put this cone here to where you can see what direction the camera is facing, and then we just have the block. And this is just a simple Unreal Engine. Well, let me take that back. This is a Pi character that comes with the Unreal Python plugin, and you can create new characters just like in Unreal, but the difference is you have to have a Pi character, and they also have a Pi component and things like that. And again, watch the earlier video, and I go over how you have to download or show the website to get the Python Unreal Python plugin. This is a separate plugin than what what Unreal can do with its plugin, which will only work in editor mode. So what we're doing is we're using it in game mode. Anyway, so we have this character here, and it's got a camera, and the Python code for it is this. And you can open the Python editor, window, if you have the plugin, and you'll see this Python editor. So the previous video we already went through the process of getting a 2D render target, which is the camera, and I won't go in a lot of detail on that because I've already done it. And what I did is I added in my PyChart class the code for not only doing the scene capture, and basically we're getting what the camera sees, and then what we're also doing is creating this ZMQ task that is basically using the Python 0MQ library. The reason why we're using that is because it has the ability to do different kinds of messaging topologies, but it doesn't use a broker. And I've got other videos that I talk about Pi 0MQ. So just as a refresher, begin play, what we do is we create that thread, Pi 0MQ thread, and then we start, and then end play, we shut it down, and then for every tick, we go through and we get the actor rotation, and we rotate the actor, which is the pi character. But what we also do is we get the render target that's attached to that character. Pull out, we're using NumPy to convert the data, and then we set that data on ourselves, and it's a global variable. And down here we have object label. This is the way we are going to return the data that comes from the server over here, which is the object identification. And this is the new part of the code, which is I'm serializing JSON and sending it over the wire using 0MQ back to the Unreal. Let's save that. So what happens is this character becomes alive, and it creates this thread, and this thread looks and sees if we have any data. This is kind of crude in here, but it works. And we globally we have our state data, which is up here, and we have the current command, which is get an image, and then we have a label, and then we have the object box. So we want to know what the label is basically what object was detected, and the object box are the coordinates within that window that was sent. So this is a little bit different from some of my other videos where I'm using almost the same code and I'm controlling a character and moving the head around and things like that. On this example, what we're doing is if we have data, screen data, we are sending it to this server over here that's doing the object detection for us. And this is how you do a multi-level socket message in Python 0MQ. We immediately wait to receive the information back, which is the JSON payload, and then we print out this object box just for debugging, and then we set our data, and we got data to false. So this structure right here also lives over in here. So this is the server, and the server is the one that has this object detector in it. Now this object detector, if you go back some of my videos on Halloween last year, it's just a wrapper around the PyImageSearch code turned into a nice little class that you can make it, let's see, it's right here, make it a little bit easier to consume someplace else. So this is that class. These are the objects that the neural network can identify. This is hard-coded. This is trained inside of the PyImageSearch's model. And it uses a cafe model, which we're not going to use anymore. And here's the proto and the model right here. And this is how you load it in OpenCV. And the version of OpenCV I'm using can do this. It can also do TensorFlow, but we're not going to use it for TensorFlow. what we're going to do is write our own object detection engine using Keras and TensorFlow. We'll still have it in a class like this, and it'll still be instantiated over here like this, but it won't use the OpenCV version. And I've kind of gone over this in previous videos. This is standard, procedure object detection code if you want to use the PyImageSearch model, which is this and this, inside of OpenCV. So I'm not going to go in a lot of detail with this, other than I modified it to where it not only returns the label, but it also returns the object box of the particular item that was identified, and then it also has the image itself. And the reason why I'm doing that is I use this class in other examples. But for right now, all we're using is the label and the object box here. So now we come over to the server, and as we can see, we're instantiating the detector. More notes, same notes on what it can detect. Let's shoot down to the bottom on the main, and basically we just create the rep task. As you notice, this is a RAQ task, and this is the RAP task, and those are types of data channels in 0MQ, and you'll have to read up on that, on how they work. But basically the thread code is the same. We are using a little bit of whatever it's called, Python tickle, to send commands, but for right now that's not being used. All that's really happening is we've got the this class, which looks literally almost identical to this one over here. The difference is this one is listening. This code over here is client. This code is server. They almost look identical, other than you see that rec there and you see the rep here. So this thing sits in a loop, and it's got an instance to the detector and the state data. As you can see, it's identical to what's over here. And then basically, again, code looks almost identical, other than we none out the state data. And if the client over here sends a send image, then as you can see, you receive here again once, and then you receive again. Then you get the data buffer. Now, I know how to fix this right in here. I'll do it later on, but basically what you have to do is convert this image data into something that the model can predict, and it has to be the right tensor shape. And for right now, the easiest way for me to do it is just write that image data to disk and then read it back out. It's no big deal. I've got a super fast SSD hard drive. It's basically almost in memory. But I have a hack here. I know how to swizzle this data. I've got other examples of doing it, but every example that I work on where you grab the screen, it's always a little bit different, and the model, it has to be exactly right for that model to work. Anyway, you run the model, you do a prediction with that image, you have your results, and then you turn around and you go through the results, and we pull out the label and the object box from the results, and then right here, what we're doing, we're saying, hey, is it a person? So we're making a distinction right now. And this code is almost identical to the Halloween project that would play recordings, WAV files, if a person showed up the door to get candy. That's another video. You can see it down the road on my channel. I suggest you look at that. This is a cute little class. PyImageSearch has been really helped me out a lot how to learn the stuff. But what we're going to do is we're going to write our own object detector in the next couple of videos. So what we do now is we send out our state data as a JSON string. So we're doing the prediction in here, and then we are sending the prediction back to the client. So then we come back to the client, we see the receive right there, the state data, and then now we can access the object that was found. So the next thing that's going to happen is that once the character detects a target as a person, then it's going to have to take the coordinates and point in that direction and start heading in that direction. Now this, let's see, let's go over here, event graph. So here's a little bit of the secret sauce with using the Unreal plugin, Unreal Python plugin. So when you install the Unreal Python plugin, it gives you these function calls, and this was the next kind of piece of the puzzle, which is the character class. This thing right here, which is this thing right here, it's got this state data that's being updated, and then we're reading it here and or here, and that's what this method is doing. So I just, on begin play, I set up a timer every 1 second. It's in a loop. It calls this event, which goes in and it gets the PyCharacter method string. It calls that method on the PyCharacter. And you have to right click and let's see, Py wrapper, Py user. All these classes get added when you install the plugin. So now we're inside of the blueprint, and all we're doing is taking those coordinates and printing them out. The next thing would be is to parse them out, or parse them out and here, break them apart in here, and or do some calculations and find the center point of the box in here, and then that would be a potential target for the object to head towards. So let's go back over here. The servers, let's make sure, is it running? Doesn't look like it. Okay, so let's kick this guy off. You got to make sure this is running first. Here's the tickle. It's got the quit command. Let's move this over here, and the server's listening. Then we come over here and we say go. And then as you can see, it saw something, and it fills this up, and it should eventually clear out. So that's the next thing to work on, is keeping the JSON clean. If I click on this and I move the ball around, it doesn't really matter. So as you can see, it's seeing something. So over in here, image receive, it's nothing, and then all of a sudden it comes across and it prints this stuff out. Now there's a second delay, and this can be cranked up relatively higher refresh rate. So he's spinning around, and then as you'll see when he gets close over to here, then the characters. Let's see, did it do it? It looks like it's yeah, there's one and there's one. So those are the coordinates over here, and then they show up over here. It doesn't really matter what happens on the server because we really care what's happening in Unreal. So we hit stop. All right, so that is getting closer to what we want. We can turn up the refresh rate and maybe highlight the characters. This particular character has an AI controller, and it has a tree, a behavior tree. It's not hooked up right now, but it can be hooked up. So here's the behavior tree, which is go to the start, do random movement, then move here, move to it, and then wait. So what we can do is later on, now that we know the character coordinates coming in over here, we can translate that and then set a variable on the blackboard saying, hey, this is where we thought we saw something, start heading in that direction. So that's going to be the next video of playing around with hooking the behavior tree back up. And we can do it right now if I go into this guy. I got to figure out how to do it again. Let's see. He doesn't have, it's not set. And I only experiment with this stuff. I've got a full-time job, so I'm writing code all day, and I'm getting tired. But I wanted to put this video out because I haven't put one out in a while. I've also got another video on the moving the characters' joints around and head and things like that using the same kind of client-server process, but that's more for experimentation. That project. This project is what we want to do is we want to grab the images out of the Unreal world, though we want to send them to our Python server because we might want to do training, right? So we might want to kick something like this off that's going around a complex world, and it's streaming those images out to this server, obviously with different code, and that server is grabbing those images and squirreling them away, and then eventually that gives us a training set. Once the training set's trained on the model, then we come back to code like this to where we're just running, we're doing inference on the model. That's what they call that. So and we could do, following roads, self-driving kind of play around car things. You could do whatever you want, but you have to have this infrastructure in place. Anyway, let's come back here. That's done. Viewport. Yeah, I can't remember. I know how to turn on the behavior tree. So that's it for right now. This is kind of a ramble, and eventually, again, I'll get the code up on GitHub to where people don't have to type, all this in. The biggest hurdle is going to be the integration with Unreal Python plugin. I'm currently reaching out to the original authors of the plugin. They don't have a Unreal 4.25 version. It only goes up to Unreal 4.23, and there's two different versions of it. One's embedded, which I don't care about, and the other one is the external, which is this version I'm using here. I'm not going to write a game that's using Unreal Python plugin, but what I might do is use the Unreal TensorFlow plugin inside of a game, inside of obviously Unreal. But before you do that, you've got to have a client server environment to train, get the model trained. And we'll go into more detail as that goes along. So I know I needed to get this video out, and it was bugging me. I'm going to get another video out on the character animation using the Unreal plugin, Unreal Python plugin as well. But I tried to do both videos at the same time, and it was just incredibly confusing for me, and when I get tired. So this is where I'm going to leave it. I hope you enjoyed the video. The creating our own models and doing our own object detection and then running that inside of Unreal, I think is going to be really slick. And all I'm doing right now is trying to recreate the work I did a year or so ago in Unity. So I'm really trying to get Unreal, at least from my perspective, up to speed to where I can do ML experiments. And maybe they're working on that, and I won't have to use Python. But Python is the lingua franca, for machine learning. And that's not going to go away anytime soon. Anyway, if you got this far, you're awesome. Thanks for watching the video, and I'll check you next time.